Hey, so I'm back, and I just wanted to expand upon the random number generator for a little bit more to understand what it's actually doing. Because you know you want to be sure your random number generator, is actually making a random number. So it's not just a coincidence that the numbers, you know, are random, right? Um, and every time I run this program, there seems to be no basis for the numbers that we're getting. The numbers appear random, and effectively, they are random for our purposes because there's no pattern. It can be 1, then it can become 21, and just some random number based on what we're doing. But what is this thing actually doing? Like, what if we do something like, not 49, but what if we do 3? What's weird is now that we're seeing big numbers right here and small numbers right there. So it appears that this algorithm isn't actually as random as we thought. If we do let's drop it down to 2. These two numbers are big, and these are small. Likewise, if we do 1, this is gonna be 49 every time. And if we run it again, it's still 49. And if we were to do 5, just as I would suspect, big numbers right here on the first 5 and a small number after that. So there is a pattern. And why is it doing this? That is weird. Well, there is a way to explain that, but before I do that even, I want to check this out. K seems to be apparently doing something that's well, let me grab these notes here. So yeah, upon further inspection, I don't see the purpose of K. If we were to get rid of this and get rid of this, because Y equate K to both nums, right? Y will num arrays, and just simply do this. What difference does it make? We still get some bizarre, odd, random numbers without it. So yeah, what was the point of that? Well, let's try this. This is going to be interesting. So right now, if we just keep running it like it is, you'll see some big numbers like 47, right? Let's do a big chop and say 30. All of these are below 30. Run it again. 28. Let's chop it down to 20. And the modulus is working like you would think, because now with the modulus, it's like a number ceiling. It won't go any higher than that. We go 10, and look at that. It will always be single digits, or it'll match 10. It'll never go bigger. If we do 3, that's going to kill the variety of numbers, right? It should pop 2 at some point. Yeah. By cutting the K's out, it's stopping the swap action. But if we leave the K, it will do the swap action, where it's doing this weird thing where it's getting 49 out there and some other really large numbers. Well, that's if you limit the amount to, let's say, 4. You'll always see 49 and then some large numbers. So to explain what this weird thing that it's doing, it's best if we add a simpler array followed by a cout end line to break to better organize the data. So I'll do this, and here's another array where we load up with 1 to 6 digits. Another loop, and if we run this, you get these 5 lucky numbers that look like this. You run it, and we always get 5, and then some large number, and then whatever else, but this one's larger. So it's actually doing some sort of swap action. And to explain what's going on in here, I'm gonna have to get some notes out. But first of all, on our old loop, the numbers of the first 3 indexes swapped until we reach the last number 49. There are other numbers that are left over that are usually large due to probability. That's what's happening if we were to do this. You get 49, you get these, and then you get these random small numbers left over. Really weird. But once I get this out, everything should clear up. So let's observe this main for loop. So first on here, I equals 1, I less than 6, I plus plus, then the num array equals that. And we're going to be using 6 array elements instead of 50, so we can see what's going on. And 100 right here is just a junk value because, you know, when we count the elements 0, 1, 2, 3, 4, 5, we initialized at 1 and forward. So 100 is just a way to say that it's a junk value. In the first iteration, it chooses the index 1 and then swaps with the value of 1. So the index 1, where we're manipulating this, becomes 1 right here. It forces 2 to take this place, and then the rest of it remains the same, 3, 4, 5. Then the iteration next to that, let's say the value chooses to be 2 again, and then it swaps with I with 2. Well, it does absolutely nothing because we do 2 right here, because we choose that. Well, it doesn't do anything. Because value of 2 is swaps with, yeah. And I don't think that should be 2, but rather 1 is what I meant to say. Because 0, 1, and then such. Okay. Then after that, it chooses 1 and then swaps that with 3. Okay, now 3 changes from 2 to 3, and then the rest of the numbers shuffle in this order where it becomes 1 will be there, but 2 would have to take 3's place because it has to belong somewhere. Then now it chooses 1 and then swaps with 4. So it chooses the first index and then it swaps with 4. This will remain the same. This will remain the same. 3 will take that place. Now it chooses 2 and then swaps that with 5. So it chooses this. It takes 5. 1 will be forced to be there. And then you end up with this result by doing something like this. And if we were to just get a random number, in this case, it did this iteration where it forced it chose the first element to be 5, and then it kind of just gets the rest of the numbers kind of naturally placed into where they want to exist. Now, sometimes it could be an odd scenario where instead of choosing 5, it could choose something like 1. Well, here, let's go ahead and do this, where it will be like so if this never happened, like snip that out, and this thing didn't choose this 2 to be 5, it chose this to be 5, it will look like this: 5, then this will be 1, of course, then this will be 2, then this would be 3, and this would be 4. So it would look like that if we were to have this manipulate, and that becomes 5. 1, 4 would be right there because it, these guys never changed, but because we put 5 here, 4 would have to assume the position over there. And then 0 indexes junk value because we never initialized it to anything. I mean, look, we did I equals 1, I equals 1, and then we changed the numbers after it, and we never ever bothered to touch 0. I mean, if we're bored, and that's a redundant glitch, I didn't mean to do that. We could say I equals 0, or nums 0, and there's our junk value we never initiated. But that's just beginner stuff, and I just got bored and just wanted to show you that. Other than that, I think we see what it's doing. So if we were to take away the k, it'll use the modulus and cap the numbers. If we throw in k, then it does that weird swap action down there that gets us those numbers.